Chemical equations are like the language of chemistry. They describe what happens during a chemical reaction. In a chemical equation, you will see the reactants on the left side. These are the starting substances. The arrow in the middle points to the products on the right side. These are the substances formed by the reaction. Every chemical equation is a shorthand way to show the transformation of substances. It uses chemical symbols and formulas. For example, the equation for water formation is H2 plus O2 equals H2O. Here, H2 and O2 are reactants and H2O is the product. Chemical equations also tell us the state of each substance. You might see S for solid, L for liquid, G for gas, or AQ for aqueous solutions. This is important for understanding how substances interact in different conditions. Understanding chemical equations is the first step in learning chemistry. They are powerful tools that help chemists communicate complex reactions simply. Once you grasp this concept, you can explore the fascinating world of chemical reactions. Balancing chemical equations is crucial. It ensures the law of conservation of mass is followed. This law states that matter cannot be created or destroyed in a chemical reaction. Balancing ensures that the same number of each type of atom appears on both sides of the equation. Without balanced equations, it would be impossible to accurately predict the amounts of products formed. It would also make it hard to determine how much of each reactant is needed. An unbalanced equation might suggest that matter is either lost or gained, which is not possible in a closed system. Balancing chemical equations helps chemists understand the proportions in which elements react. This is important for practical applications. For example, in industrial processes, precise amounts of chemicals are needed to ensure reactions proceed as expected. In summary, balancing chemical equations is not just an academic exercise, it is a fundamental skill that supports the accurate study and application of chemical reactions. Learning to balance equations is a key part of becoming proficient in chemistry. Balancing a chemical equation might seem tricky at first, but it becomes easier with practice. Let's break it down into steps. First, write down the unbalanced equation. Take note of all the reactants and products involved. Next, count the number of atoms for each element on both sides of the equation. Compare these numbers to see which elements are unbalanced. Start by balancing the elements that appear in only one reactant and one product. Leave hydrogen and oxygen for last, as they are often in multiple compounds. Adjust the coefficients in front of each compound to balance the atoms. Coefficients are whole numbers placed before the formulas. They adjust the number of molecules without changing the compounds themselves. After adjusting the coefficients, recount the atoms for each element. Make sure they match on both sides of the equation. If they do, the equation is balanced. Practice this method regularly to become confident in your balancing abilities. Section 4. Practical example. Balancing water formation. Let's apply the balancing steps to the formation of water. Start with the unbalanced equation. H2 plus O2 equals H2O. Count the atoms. There are 2 hydrogen atoms and 2 oxygen atoms on the left and 2 hydrogen atoms and 1 oxygen atom on the right. To balance, adjust the coefficients. Place a 2 in front of H2O to balance the oxygen atoms. H2 plus O2 equals 2H2O. Now recount the atoms. There are 2 hydrogen atoms on the left and 4 on the right. Adjust by placing a 2 in front of H2. 2H2 plus O2 equals 2H2O. Check your work. 4 hydrogen atoms and 2 oxygen atoms appear on both sides. The equation is now balanced. This method ensures the law of conservation of mass is followed. Practice with different reactions to master balancing equations. Section 5. The role of balanced equations in chemistry. Balanced chemical equations are pivotal in understanding reactions. They show the precise ratios in which reactants combine and products form. This knowledge is essential for predicting reaction outcomes. In industrial settings, balanced equations guide the efficient use of resources. They help chemists determine the exact amounts of reactants needed. This minimizes waste and optimizes product yield, making processes more sustainable and cost-effective. For students, mastering equation balancing is a stepping stone. It opens the door to more advanced topics in chemistry. It demonstrates the interconnectedness of science, math, and logic, fostering a deeper appreciation of the discipline. In conclusion, balanced chemical equations are more than just symbols and numbers. They are fundamental to understanding the world at a molecular level. By learning to balance them, you gain insight into the nature of matter and the principles that govern chemical change.